Okay, last one. What we need to do now is design and build a voltage divider, right? Another name for this is AKA find unknown resistance by measuring voltage. And we could also call this AKA build an Arduino multimeter, or specifically ohmmeter. I'm not sure if ohmmeter has two M's or one M, but it doesn't really matter. So here's the little trick, right? We're going to design a little circuit that looks like this. And then it goes like this. And then it's going to go down like this. And so we're going to supply it with some known voltage. And we're going to call that the voltage that we're going to put in. We're going to connect one end of it to ground. V ground, which equals 0 volts. And we're going to measure the other end. We're going to call this V measured, right? And so this, the V measure, I meant that to be blue. Let's go back to blue and make it a little wider. So we can measure this voltage with Arduino using the analog input on our Arduino. And then we know this. We're going to need, so we'll use the Arduino has a very carefully controlled 5-volt power supply on it, and then we can measure. So we're going to supply voltage, we're going to measure voltage, and then here we're going to have some reference. I'm going to have some, what I'm going to call R ref, right? So we're going to say this is in blue again. So this will be, redo, no. So this will be a resistor, a known resistor from kit. And that's what we call our reference, or something that we know. Typically when there's a reference, it's something we know. And then we're going to call this one our, I should make that neater. That'll be our UNC, for our unknown. So we have a voltage in, and we have a reference voltage. We measure some voltage. We have some unknown resistor that we're trying to find. So perhaps our potentiometer. And then, we've got one more problem here, is that we have another unknown resistance. So I'm going to do, well, I'm being inconsistent with my colors here. So I know my current, some of the current is going to go this way. But then for those of you who have studied some circuits, you'll know that there's also going to be some current that flows this way. Okay, so that's a little problem because now we don't know, we've got a bunch of current flowing around. We don't know where it's going. But fortunately, we have something in our back pocket, as we know this. We know the Arduino resistance. is 1 mega ohm, right? That's 1 million ohms. And that's done very intentionally, right? Because now really what our circuit will look like, we know that, this is going to be very, very little. So this is going to be very small because this resistance here is huge. That's huge. So very, very little current is going to flow down through the Arduino into the measurement. The vast majority, we're going to neglect this, the vast majority of the current flows this way. So I can say that most of the current is going to do this. And then a tiny little bit of current is going to go this way, which we're just going to neglect, right? That's you'll learn that we do that a lot in engineering. We say, that's so small, I'm going to ignore it. So our circuit practically looks like this. So I've got a node here that's Vin. I've got some reference resistor. I've got some unknown resistor. And then I've got ground. Right, and oftentimes you'll see this, it looks like this when it goes around. So this is 0 volts. This is Vin. And this is where Cece is going to come in, my daughter, and she's going to measure a voltage right there that flows through our reference, our unknown, right? Okay, so let's see, how much room do I have on this page? Not much. So we'll go to the next page here and figure out how we can make this work. All right. First, let's go to, let's remember Ohm's law. Ohm's law. And that says that the current equals the voltage difference divided by the resistance. Okay. So for our particular case, for the whole circuit, we go back here and look. Let's see, what does the whole circuit look like? The current is going to go, the voltage is the input voltage, which we know is 5 volts down here, and then the out, the other end is 0 volts down there. So that's the voltage. So the current is going to be Vin minus 0. And then the total resistance, so we're going to ignore the Arduino resistance. So the total resistance is just the reference resistor and then the unknown resistor. All right, so this is our ref plus our onc, right? Well, Vin minus 0 is just V, so I'm going to say that I, for the whole thing, equals Vin over the sum of our two resistances, RF plus our onc. Now, this is a pretty important intermediate step, so I'm going to put a box around this, like a dotted box. It's not my final answer, but this is going to be pretty important to me in a little bit. All right, so now I know how much current is flowing through this whole thing, the big red line. I know how much current is there. That is the input voltage divided by the sum of the resistances. All right, well, now let's just look at, let's go back to here. Let's just look at our unknown resistance, right? Because that's what I'm interested in. Well, Ohm's law still applies. So I equals V over what is it, V over resistance, right? And so for in this particular case, it's I equals, well, what's the voltage difference? It's, what is it again? It's, okay, it's the measured voltage minus 0, all right? So V measured minus 0 divided by, what's the resistance of the unknown resistor? Oh, I don't know what the unknown, okay, all right. So it's our unknown. All right. But here's the thing is, let's write this one more time. Let's write I equals V measured over our unknown. All right, and so that's an important intermediate step. I'm going to put a blue box around that too. But what do I know? Let's see. I know my V measured, right? Because I'm gonna put a green check by things that I know. So here's, make it a brighter green. No, that's fine. So I know my V measured. But I only know one thing. So now I've got a problem. I've got two unknowns, and I only know one thing here, so I can't solve it. Or can I? Oh, let's go back and look. We decided that effectively all the current flows through both resistors, right? Because there's so much resistance in the Arduino, all the current is going to flow through both those resistors. So I do know how much current is flowing through the unknown resistor, right? All of it. So I do know this. So this really is this. They're the same thing. So now I can write that, actually, you know what I'm going to do? I'm going to solve this here because what I'm interested in is my R unknown. So I know that my unknown resistance is simply, let's see, that goes on top, that goes on bottom. So V, my measured voltage divided by my current, right? But I know my current from before, so I can say that my unknown resistance equals the voltage I measure divided by my current, which is V in divided by R ref plus R unknown. R ref plus R unc. Well, that sucks. Now I know my unknown voltage is a function of a bunch of stuff I know and my unknown voltage. So I guess we got to do some algebra. That's kind of a bummer. So what do we do here? I guess I can multiply both sides by this thing, so I can write, how much room do I have? Not much room. Well, let's try. So R unknown times what's down there, Vn, divided by Rf plus R unc equals, let's see, V measured. Right, now I'm not a particular fan of fractions, so what if I multiplied this thing to the other side? Let's try that. So that means, believe it or not, I really don't like fractions. So R unknown times my input voltage equals my measured voltage times R reference times, or plus my R unknown. Every time I write that, it looks like punk, and I think of like Husker Du or the Minutemen or Suicidal Tendencies or somebody. Anyway, so that's, okay, what I can do now is say R, I'm just going to distribute this right side, so my unknown voltage times my input voltage equals V measured times R ref plus V measured times R unknown. Ooh, and now what I could do, if I could get those all in the same, so I'm going to move all my unknowns to the other side. All right, so let's start a new page for that maybe. So now I'm going to say that, I just, how did that go again? Okay, so I got to subtract V measured R unknown, all right. So now my next line is going to be the R unknown times my V input minus my R unknown times my output, or V measured, and that's going to equal my reference resistance times my V measured. Right? I think that's right. Now what I can do is factor out that thing there. So R onc times the quantity input voltage minus measured voltage equals my reference times my V measured. Ooh, now this looks good. So now I can solve for R unknown. My R unknown equals my reference voltage times, let's see, it's V measured divided by Vn minus V measured. Good. So really, I could have huge resistances, and as long as I get, let's see here. So the V measured. So ideally, let's take a look here. So I'm going to go back to this. So I'm going from 5 down to 0 eventually. So I just feel like it'd be nice if I if my reference voltage was pretty close to my unknown voltage. So if I picked those in even 50-50 split, let's take a look. What would happen if I did that? I mean, it would require a pretty good guess, but so let's put a nice black box around this, because that's that would work out pretty slick. So if I said if I made a lucky guess, and picked our ref equal to our onc, what would happen? So that would mean that, and let's divide that over. So our onc divided by our ref equals V measured over V in minus V measured, right? But so this equals 1. Let's make that a blue line there. Blue. I like to make notes in blue. So this equals 1 from my lucky guess. So that means 1 equals V measured divided by Vn minus V measured. And then so that means that my Vn minus V measured equals V measured. That looks a little funny, but add that to the other side. So Vn equals 2 times V measured, or V measured equals 1/2 of my input voltage, right? And this is kind of important, because what I don't want to happen is have drastically different values here, right? Let's say I knew that, if I picked a 100 ohm resistor for my reference and I had a 5 kilo ohm, right? I'd wind up with really huge or really little numbers, which are kind of hard to measure. It'd pin me all the way to one side or the other of my voltage, right? Whereas if I guess well, then I can, I'm going to operate right in the middle of my voltage range, right? So matching resistors, and that is V ref is approximately equal to V onc, right? Allows me to operate to measure in the middle of my voltage range. Great, which I like to do. Okay, so with that, I think you now have enough information to figure out, to go all the way back and then figure out a little something about your potentiometer. Okay, that'll be lab number 4.1.